Now we're going to look at an example that requires using the chain rule. Let's start off with two functions. F of x is 9 plus 5x squared, and g of t is radical t. Well, what do we know about these? Well, first of all, the domain of this function will take the usual domains. Well, the domain of this is any real number. We can plug x, any value of on the real line, into f. The domain is all real. The domain of g, though, is 0 or positive numbers. So the domain is all negative numbers. And remember, this could be written like t to the 1/2 power. Well, we're eventually going to compute the derivative of this function, g composed with f of x. In other words, g of f of x. Let's first figure out if this is legal to do. Remember what we're going to do. We're going to do, for this, we would need to compute f of x and get a number out, and then plug it into g. So we have to ask ourselves this question. Is the image of f a subset of the domain of g? In other words, does this make sense to do? Well, what is the image of f? Actually, I think the way we wrote it in the theorem was, what is f of r? That's the domain of f. So this will give us the image of f. What values can come out of this? Well, if we think about it, I'm sure we'll figure it out simply. 9 is 9. 5x squared. Well, x squared, what's the smallest that x squared can be? 0. So the smallest that this can be is 9. And it can go all the way up to infinity. So this looks like it's the image of f. And what is the domain of g? The domain of g was simply 0 to infinity. So yeah, we have a subset. So no matter what value I plug into f, I'm going to get a number from 9 to infinity, and any number from 9 to infinity can be plugged into g. So this does make sense. And we can use the chain rule to find the derivative. So let's note, before we do the derivative, that f prime of x is equal to 10x, and that g prime of t is equal to 1/2 t to the negative 1/2, which I could write as, let's see, 1/2 radical t. And that's by theorems 4.3 and 4.5. I'll just make a note here. Theorems 4.3, 4.5. Allow me to say that and that. Okay, well now we want to get f. This new function, capital F, is g of f of x. And for us, that's equal to g of f of x by the definition. And that would be what I get when I plug f of x, this, into g. So that will become my t. So 9 plus 5x squared under a radical. That's our new function that we want to take the derivative of. And I did make a note that what we already set up here, well, just for practice, what is the image of capital F, or the range of capital F? The domain is all real numbers. And radical 9 plus 5x squared, well, if x is a 0, we're going to get the smallest possible number. which would be a 9 under here. And as x goes in either direction, the number under the radical is just going to get bigger. So the image of f of x is going to be 3 to infinity, square bracket on the 3. All right, well, that wasn't necessary for us for this problem, but by theorem 4.4, which is the chain rule, we can get the derivative of capital F. Well, first of all, we know it's differentiable, but we can also now use the chain rule to compute the derivative. So, f prime of x is equal to, by the chain rule, g prime of f of x times f prime of x. All right, so we've already computed what g prime of t is. So this would be, instead of t, I'm going to have f of x underneath it. So it's going to be 1 over 2 times the square root of, instead of t, I'm going to put f of x, which is 9 plus 5x squared. That's just g prime of f of x. So we plugged a g prime, we plugged f of x into the function g. And I guess g prime. So we just replaced the letter t, here it's easier to see it here, with 9 plus 5x squared. And now we need to multiply by f prime of x, which is just 10x. So we get final answer for the derivative of capital F. The 10 and the 2 would cancel, giving me 5x on top over radical 9 plus 5x squared. That's it.